Okay. And let's talk about your next deliverable. This is always one of the toughest lectures because, and if I can, I'll get this done in time so we can do a biology break ahead of the class gap. Your next deliverable is your architecture and design document. Again, given a short time frame, so on and so forth, I don't expect a large document here. Let's go through slides. What is software architecture? Which, by the way, still remains something of a contentious issue within software engineering. You know, what is architecture really? It's your fundamental organization of the system you're going to do. It's sort of like, here's my 10,000 foot view of the system. Here are the different pieces, how they're going to fit together. At Pages, the architecture which I drew up, and I've already mentioned this, was the major components of the application and how they talk to each other. It was the compositional architecture of the document object itself. How all the components fit together. In other words, when you had a document, here's basically the internals collection of objects that are all pointing to each other and how they do it. And then it was the class hierarchy. Those were the three major diagrams I created. I worked on them for several weeks, continuing to revise them a little, and as I mentioned, they were on large graph sheets of paper in color. And I went down to Kinko's and got full color, full-size copies of them. And for each new engineer that we hired, I would give him those three sheets. And then sit down and say, okay, this is what we're building, and this is what all of this means. So the idea is, what are you building? What are the key requirements? In other words, does this need to be, how extensible does it need to be? How responsive does it need to be? What are the constraints on the overall system? What are your choices? And some of you have already listed this down. A lot of you in your requirements documents said, okay, here are the technologies we're using. So a lot of architecture is your choice of technologies, which may be mandated by the company. None of you have said that. I'm working at company X and we have to use this. Therefore, any solution we have has this. So that is an architectural decision. And this last point is important. It requires negotiation and buy-in among team members, managers, and users. Architecture is a political act. One of the chief roles of the chief software architect is to convince everyone else to listen to her or him. Say, this is why we're doing this. And it's also turn around and listen to everyone else who has input and say, that's a good idea. That's something we should put in there. If you're a good architect, you are getting solutions from whatever direction you can. And then you're presenting people back and saying, based on what I've heard, based on what I understand, based on my expertise in software architecture and design, here's what I think the best solution is. And then you have to try and enroll people in that. And again, this is one of the reasons why I think it's so important to have the project manager and chief software architect, these separate roles. Because they are often at odds with each other. And there needs to be some serious negotiation between them when those issues come up. Here's one of my, I don't know if I want to say favorite stories, but here's probably one of the more striking stories. And I'll try to obscure it to protect the guilty. I was managing a large team of consultants at a major corporation, Fortune 50 corporation, and there was a project going on to build, in essence, a object technology infrastructure to make application development both faster and more robust. And we had a brilliant software architect who was in charge of it, but unfortunately he was also acting as the project manager for that. So he was the one estimating the schedule. Now, this was late. It had been late several times. It had slipped several times. The vice president at this corporation who was over all this, who was the person I directly interacted with, finally went to this architect and said, okay, what I need from you, because I've got to sell this upstairs, I need you to give me your best. He says, you have carte blanche right now to revise the schedule. I want you to give me your best estimate as to when you think you're going to have this technology framework working. And this all happened without me being in the loop, or else I would have hit him over the head and prevented it. And after he went away and thought about it for a few days, and he came back and said, I need 3 more weeks. But she came to me and said, is he an idiot? Said he could have asked for 6 months, he would have gotten 6 months. Said, I know he's not going to be done in 3 weeks. But that's what he's just told me. And that's what I have to pass upstairs, and he's going to slip again. And he did. And it really was more like 6 to 9 months before it was done. You need, you need, project manager needs to control the box around the chief architect. The chief architect needs to give the project manager the best possible estimate as to what the work's going to take. And like I said, the two of them, if I had been, I had not been in the loop on that. I should have been. I was not put in the loop on that. If I had, and this architect had come back and he said, oh yeah, 3 more weeks, I'd say, no, it's not. I've talked to the other developers. We're not 3 weeks away. We're months away. Why are you giving her 3 weeks? She was very frustrated and upset, rightfully so. And the problem, the danger of being overly optimistic and misestimation is that when you do miss your deadlines, and again, I was a year late, you look either dishonest or incompetent. And I got into the whole issue of project management when project late, because as I said, as I told you, we were a year late shipping pages. I can't tell you how painful that was, professionally and personally. And it made me rethink everything I thought I knew about software development and project management. Okay, some definitions of architecture. Like I said, you will find varying definitions from all sorts of places. The most abstract depiction of the system that enables reasoning about critical requirements and constrains all subsequent refinements. You want your architecture to draw a circle around what you're building. Nothing you build should move outside that circle. If it does, then you've missed some part of the architecture and you need to go back and revise it. Another definition. Architecture defines that system in terms of computational components and interactions among those components. Boxes and arrows. The simplest software architecture is boxes and arrows. There's this point, there's this part, there's this part, and they're talking to each other this way. And here are the APIs that exist. Shows the correspondence between the system requirements and those elements. In other words, your architecture should reflect your requirements document and should be capable of adjusting it. And it clarifies structural and semantic differences among the components and interactions. That's, yeah.
Are we talking, I guess it could vary, but I'm thinking about our project, and I feel like there's probably more classes than, if we talk about a component as being a class rather than a collection of classes. What granularity is a component? Or should it be, at least for this pass on?
For this, components, you're basically talking about subsystems that have communication. So you want, again, we're back to, I brought some nicer markers. You're talking, again, about the issue of, you've got a box abstraction of some subsystem, and you've got a abstraction of another subsystem, and these communicate to each other either through, an API, class interface, however they're communicating with each other. And this does X, and this does Y, and this interaction is constrained. That in its simplest form is architecture. There's more that you can include, there's more you can break down. When I did the architecture at ERIC that I talked about, they had 4 subsystem diagrams that did not talk to each other. And I had to look at all of those and figure out what they needed as inputs and outputs. So I had these, literally, it's like 4 diagrams, and they were missing the interaction. So I had to come up with a master diagram that abstracted these 4 subsystems and defined what the interactions were between them. And then I had to go back and refine the subsystem diagrams to make sure these were actually doing the correct interactions with each other. Okay, this is I like this thing that Recton has, a creative, obsessive juggling of requirements, constraints, technology, costs, and standards. You define your what, you define your how, you define your why. This is, and by the way, this is me giving you a very brief lecture on software architecture, because what you're going to create for this class is going to be much simpler than this. So, what your architecture should include is why your architecture will make your product successful. Conditions of customer delight, whether your customer is simply another subsystem or an actual human being. The what, your top level design, major subsystems interactions, your explicit choices and trade-offs in technology and approaches. You don't need to, for purposes of this class, you don't need to talk about that this much beyond saying, and some of you have already touched on this, or at least implied it in your requirements document, we're using React because X. Or we're using Unity because Y. Because we don't want to rebuild Unity from scratch. And then describe how your design will achieve your success requirements for your document. Design is your specific solutions. They can be design patterns. They can be, we will do this, we won't do that. And a lot of this may seem obvious, but something you may discover is you may get another 2 weeks into this and discover that you've got team members who have been coding at cross purposes. And one or more team members thought, oh, we're doing it this way, and have been writing code to that end, and then you have, some others who made a completely different set of assumptions. What your design document do is should start with your overall architectural vision and say, in order to achieve the architecture, here is what we are and aren't doing. This is what you must do, this is what you shall not do. This is the approach we're going to take with each of these. And you can do that based on UX UI, database, patterns in module interfaces. Here's an issue, and again, this is short-term projects, but I'll raise this anyway. We talk about APIs, and usually what we talk about is a series of functions, methods, whatever, that this is how you interact. You know, this is part of System X, and this is how you interact with System X. Therefore, this is Systems X API. Yeah.
Can we turn on more lights?
Oh, sorry.
I can't really see that.
I can.
Yeah, I probably shouldn't have picked yellow. There we go.
Still can't.
It's okay. I'll pick a different color then. So, what we often talk about in API, you're saying here is System X, and its API is a series of functions or method calls, you know, possibly with parameters and so on, and these each do work. The problem is that there is usually a deep interface. Deep interface says you have to call foo before you call bar. And if you've called foo and bar, you can't call Fred. What you'll find with APIs is often the deep interface is not well documented. That's where you have to get books that say, here's, if you're going to use X, this is what you have to do, and you have to call this one first, and once you've called this, you know, you can do this and this and so on. So in designing your own APIs between your systems, make sure you document the deep interface. At least to a degree that's sufficient for your team members. So, having scared you with all this, we got to do this 1 week. Here's what I'm looking for in your architecture design document. First, what you hope to achieve by it. I'm looking for like 3 sentences here. You know, this document describes our architecture design to do this. An overall view of the system architecture. This can be as simple as a boxes and arrows diagram. If you feel there's more that you need or want to do, if there's some key aspect that you need to make sure your team all understands, you can put that in. You can have design divisions based on your approach and your team. A lot of you are doing front end, back end. A lot of you are doing databases. How you are going, based on the architecture, this is the overall design that we're doing. These are the design idioms or patterns or approaches we're doing, and this is how we're going to implement it. And a lot of you are already doing this in your status reports. That's great. This document should identify what you think your hardest problems are. And a lot of you, like I said, I'm already seeing this in your status reports, like we may not be able to do X because of this, or we're not sure how we're going to accomplish this. I'll have these slides up today, by the way. And hopefully, I was having some problems with the internet and so on and so forth. That's why the lectures were up so late. I will work to get these lectures up tonight. And so, create the document, get it up on, by Saturday midnight. I'll look at it Monday morning, which means you have an implied extra bit of time. Just put it on your wiki. You don't need to send it to me. I'll look at these Monday morning, and next class we'll have each team's chief architect stand up and give us a couple minutes on their architectural approach. So all of you who are project managers can keep a sigh of relief after having had to stand up the times. Don't forget your status report podcast. Let's take about a 5-minute break. I think you can all make it to the bathroom back since you're ahead of the class break.